Okay, looks like I have the top of the hour on my clock, so we're going to get started. Welcome, everyone. I hope you're all having a good day so far. I'd like to thank you for taking the time out of your day to join our webinar. So our focus today is going to be on dams, dikes, levees, and spillways, and how you can use the GeoWeb 3D retention system to help create stable Earth solutions. So I'm your host, Sam Justice, and I'm a licensed professional engineer in Wisconsin and Kentucky with degrees in civil and geotechnical engineering. I'm one of the engineers here at Presto Geosystems, and we manufacture erosion control, stormwater management, and porous pavement products, all made in the upper Midwest of the United States. Through extensive national and international distribution networks, we offer technical and site support, as well as free project evaluation from our in-house design engineering team, which I am a part of. So today we are going to learn how the GeoWeb system can protect against erosion from water flow in a variety of project conditions, and how geocells can accommodate typical construction issues and design challenges, plus how the GeoWeb system can reduce the vertical pressure on your subgrade to allow for reduced cross sections in load support applications. So let's do a little bit of background on Presto Geosystems first, so you know who we are. So we worked with the U.S. Army Corps of Engineers to develop the GeoCell technology in the late 1970s, and we've been innovating in this market ever since. Our products have been used in over 200 countries and in every state in the United States. We go beyond simply providing a product, we provide a solution. And so we do operate in 3 product areas. Soil stabilization using our GeoWeb geocells. And those can be for load support, slope and channel protection, and constructing green retaining walls. The GeoWeb system is what we're going to be talking about today. We also offer porous pavements, which we have both a vegetated and an aggregate surface solution, and lightweight construction mats. We're not talking about porous pavements or construction mats specifically today, but if you do have questions about those, feel free to reach out. We have lots of information about those sorts of applications. So we are going to talk mostly about slopes and the hydraulic performance of the GeoWeb system. We are also going to briefly cover load support applications using the GeoWeb system. So let's start with what the GeoWeb system is, some general information about the GeoCell technology. So the GeoWeb system consists of 2 main attributes. The first attribute is going to be the cell size. That's going to be the container that holds the material. The cells come in 3 diameters, so small, medium, and large, and heights of 3, 4, 6, 8, and 12 inches, so 5 different depths. The cell aperture, so the opening and the height, are going to be selected following an evaluation of project-specific needs and site conditions. So there's no one right application. It's going to be specific to what your project actually needs. Another thing I want to point out is going to be the ultrasonically welded seam. This is where all of the connecting points are. And it's very important to the function of a geocell. The stronger the seam strength, the better the performance of the geocell. A strong seam allows for the use of heavier infill material, steeper and taller slopes, and better overall lifetime performance. The GeoWeb system is produced using a high-quality virgin, high-density polyethylene HDPE resin. And this allows for consistently strong welds at each cell junction, while also maintaining semi-rigid ductile properties within those cell walls. And it has high stress crack resistance and overall toughness for long-term durability in the environment. Our geocells don't use any fillers or exotic polymer alloy blends, which ultimately reduce that weld strength and reduce the environmental stress crack resistance. So both things you kind of want to avoid. And those sorts of polymers or alloys are offered by some competing products on the market in the name of increasing cell wall stiffness. And so you really want to avoid overemphasizing one property over any others. You want what we consider uniformity in performance. So you want it to be uniform across all the different elements of a geocell system rather than focusing on a single property such as stiffness alone. So the table on the right that you see here is a very general representation for summary purposes only. We'll obviously be able to help you determine a very project-specific application, but this could give you a general idea of the cell size and the cell depth that we might recommend for your type of project. And I do want to say I threw a lot of sort of technical terms at you. Not necessary that you remember every single one of those things. You don't necessarily have to know what environmental stress crack resistance is if you don't know already. The point is that we've thought about it and we know how to make sure the GeoCells and the GeoWeb system are going to perform at the optimum level without compromising in any one specific area. If you do have questions about any of these things, we're more than happy to talk about them with you, share our research, share our testing, that sort of thing, so that you can have that background information if you want or need it, or if you need to share it with, say, regulators. So for, excuse me, so in order to perform uniformly, which is kind of the key term that I want you to take away from all of this, even if you don't know any of the specific terms, uniformity is kind of where we're going with that. You need to have both factory welded junctions, so that's going to be those internal seams that we talked about, and then also field join junctions that connect the individual panels. Those are sort of mechanical junctions. And those are going to perform at a level that's commensurate with the cell walls. So that gives you three primary elements of how a GeoCell functions: the cell walls, the internal junctions, and the mechanical connectors. So they all must perform uniformly as a complete system. So like I said, you don't want to have an increase in just a single function, such as cell wall stiffness, if it doesn't have complementary increases in the mechanical junctions or those internal welds. You need all three of them to be equal for both increases and decreases so that you have that uniformity overall. So like I said, the GeoWeb system is manufactured using a proprietary blend of high quality virgin HDPE, that high density polyethylene. So our proprietary formula has stood the test of time for more than 40 years, contains no fillers, no unstable polymer combinations, no exotic polymer alloys, no fancy anything like that. We have a good, simple, stable product that we've been using with great success for a long time. For most typical sites, the GeoWeb system is going to retain its durability for greater than 50 years. And we've done lab testing indicating over 150 years without degradation, even at full exposure to the elements. So we stand behind our numbers so that you can deliver certainty in a solution as you build with materials that you trust. Additionally, I just want to make sure everybody is aware, especially if you are in the US and perhaps if you're working on federal projects, the GeoWeb system and all of our other products and accessories are 100% made in America. We do meet all Buy America requirements. It's pretty typical for federal or state level projects. So we would meet those criteria. We would be able to be a product that you could use if you do have those sorts of restrictions. So I just want to sort of highlight that and point that out. So the system components are the additional piece to the actual GeoWeb panel. So they're all those supporting pieces that help complete the GeoCell system and ensure that uniform performance across an interconnected system, protecting against non-uniform deformation or differential settlement. So things you really want to avoid, having these system components is going to help prevent that. So I'm going to focus on just a couple of the different accessories that we have. The first one is going to be the Atra key. This is our mechanical connection. I mentioned it briefly earlier. This is our field join junction that connects all of the individual panels to create a single web across your entire project site. So they are made of HDPE, same as the GeoCell walls. So they're not going to rust. They're not going to degrade under environmental conditions, nothing like that. Also, they are significantly faster to install than using stapling. You don't have to have an electrical stapler out there. It is all just a quick hand turn. So you can go through really quickly. Single guy can do it quite fast. So this is kind of the big key component to create a system that covers your entire project area. And so next we want to take a little closer at anchorage options. So if your GeoWeb panels are laid completely flat, you don't really need anchorage. Gravity is going to hold it in place. But if you are on a slope, which typical dams and spillways are, you're force of the weight of the material is going to require some sort of anchorage to help hold it in place. So for shallow slopes, and for us, shallow means less than a 2 horizontal to 1 vertical, about 26 degrees, stake anchorage is going to be sufficient to hold things in place. We have 2 options for stakes, one made of standard steel rebar, one made of the HDPE, which is shown here on the screen. So if you're in, say, a saline environment, if you were along a coastline, the HDPE speed stake is going to be a lifesaver compared to corrosion-prone steel. And stakes can easily be driven by hand or a power drill, like the guy is using in this photo here. Whatever is going to be easiest for your site, whether or not you have access to electricity on your site. So a tendon anchorage is the second option that you may have. It's typically used on long and steep slopes or for installations over a geomembrane. So if you were, say, in a detention pond collecting particulate matter, you might have a geomembrane that you don't want to be punctured. And you see those part of earthen dam solutions quite a bit. So it's definitely something to keep in mind if you have one of those on your site. So our Etra tendon clips are very advantageous when anchoring with those tendons. The tendons are securely fastened to the tendon clip, and then those tendon clips are attached to the GeoWeb, so there's no chance for slipping of the tendons. You have those 2 different connection points. Everything's going to be held in place. This also allows for top of slope pre-assembly, so you're limiting the amount of work that has to actually take place on the slope, so you have a little bit of a faster and safer assembly process. Okay, so with that knowledge of what the GeoCell is, how the different components all interact, let's look at some application-specific uses of the GeoWeb system, starting with the armoring of dams, dikes, or levees. So a typical earthen dam or dike application might look something like what we see here. On the wet side, we have GeoWeb armoring, generally filled with an aggregate or a concrete infill, with that infill type mostly dependent on wave action, as well as potential drawdown rates within your dam. The cells could then be expanded up over the top of the dike and then down the dry side. And this would provide a stable driving surface at the crest, so we could infill that with aggregate. And then on the dry side, we could transition to a topsoil and vegetation solution, allowing for some natural aesthetics while still providing some erosion protection should the dam overtop. So you have lots of flexibility for covering as much area on the dike as you need, and also what infill materials you may use. So I did mention that the GeoWeb system could be used to stabilize the crest for a drivable surface. So that's what we call a load support application, supporting those vehicle loads. So we're going to go into a little bit more depth on that because it can be kind of different than just this typical slope protection application. So the GeoWeb system works like this. When a vertical load is applied, the active earth pressures in the loaded cell pushes back against the passive earth pressures in all of the adjacent cells to form a stable system. So each cell helps support the one around it. So it's the orange arrows pushing against the yellow arrows. And then the GeoWeb cell walls also transfer hoop stress, which is important keeping the system intact and creating the mattress effect. So those are going to be those blue arrows. So the strength of the seams around each cell, the material properties of the individual strips, and the connection methods between the panels are all going to be important factors in determining how the GeoCell system can improve your load-bearing capacity. Strong seams, semi-ductile resin properties, and integrated connections are going to be critical for a well-performing system. The GeoWeb system and its component accessories are specifically designed to work together to be an effective solution for porous pavements, load support, all of these type of things, especially in soft soil applications or where you might have that potential for water flow due to a dam overtopping. So here you can see the stresses on a subgrade with the unsupported subgrade on the left-hand side and then the GeoWeb reinforcement on the right. Notice how there's the complete elimination of the highest stresses, so the red and orange bars, when you have GeoWeb reinforcement at the surface. The stresses are reduced and distributed over a wider area, and we call this the mattress effect. The mattress effect reduces the stress reaching the subgrade and leads to a significant decrease in the deflection and rutting that you may see. So you're not going to constantly have to go back in, refill in those ruts, try and move the material back into place because it's not going to get moved out of the way in the first place. So for this one, the top schematic shows an unconfined aggregate system and then shows how that aggregate gets pushed down and out and away from the tires as you drive across. So you're also not going to be utilizing the full strength of that aggregate because it's just getting sort of shoved away from the tires. It's not actually supporting the load. So if you look down on the lower one, the GeoWeb system greatly reduces the maintenance through confinement. This aggregate has nowhere to go. It's held in place within the actual cells of the GeoWeb system, and it's going to give added strength to the infill by adding some apparent cohesion, and that allows us to reduce your section depth. So if you are trying to go from a really thick section of aggregate, you can go down to a much thinner one using the GeoWeb system. So a couple of the benefits to using the GeoWeb system for load support include, like I said, that reduction of the cross section. We can go 50%, sometimes even as high as an 85% reduction in the depth of the cross section. So it can be a really significant thing if you have high material costs or if you're in a very remote location where it's difficult to get material to. It also controls the both lateral and vertical movement of your stone. So it's not going to get pushed to the side. It's not going to get pushed down into your subgrade. It's going to be held in place, and it's going to actually be able to support your load while doing it. And it has a high flexural strength. So you can have those very heavy vehicle loads. You can go all the way up to AASHTO H25, which is full highway rated loading for emergency vehicles. So you can get some really heavy loads with the GeoWeb system. You're not limited to, small ATVs or cars or pickup trucks. And then when we go back to sort of thinking about slope protection, it does allow for steeper, stabilized slopes that are going to be resistant to erosion. So you're going to be able to go from, a really shallow slope, maybe think of 4-to-1, you could go up to a 2-to-1, maybe even a 1-to-1 based on project conditions. So it gives you a lot more flexibility with your site space, how steep you can go, what your footprint needs to be, all of that stuff. So doing this allows for a lot of good flexibility on your site. So the GeoWeb system is going to be a more economical alternative to things like large riprap or reinforced concrete for dam faces and spillways, and can even allow for vegetated faces that otherwise would not be possible due to the hydraulic forces at play. So that's definitely something to keep in mind, what your material costs may be. If you know that it's really hard for you to get stone to your area, or it'd be really difficult to get concrete all the way out to where your location is, and you have soil on site, you can use that soil and grow vegetation with the GeoWeb system where you might otherwise not be able to. And if rock is used, the GeoWeb system allows you to greatly reduce that rock size. So you're not going for the large engineered riprap stones. You can go for your standard small aggregate. And then with concrete, typically we can cut the required concrete depth in half or more when compared to a heavily reinforced concrete section. So all great benefits for the different types of materials you may be able to use. Again, giving you that flexibility on site to get you the best solution for your particular project instead of the one size fits all. This is just going to be a vertical slope section for the GeoWeb when using it for a slope protection. So think of your reinforced dam or levee faces. So this shows how you might do some anchorage, whether you do stakes, whether you do the tendon system. If you do tendons, you are going to require some sort of crest anchorage, whether that's going to be a buried pipe deadman. You could get away with earth or rock anchors if you have limited site space, that sort of thing. So this is going to be sort of the typical what you might see on site. You wouldn't necessarily have every single one of these pieces every time, but it is what could potentially be out there. And you do have some structural and stability benefits on slopes as well. By holding that infill in place, you're preventing sloughing or sort of mass movement of soil or stone on slope faces. That's going to allow you to go to those steeper slopes because you can have those that soil confined within the GeoWeb panels, so it's not going to have the ability to move. And then it's also going to limit the amount of undermining that potentially could happen because it's not going to allow fast water movement to, slough off the surface and then start creating undermining, because the water is going to be able to flow over the top of the GeoWeb system. And it does support a variety of infills. I've mentioned this a couple times, but just to really highlight what your options are, you can use soil to grow vegetation, so you get a nice green living wall, or you can do stone. So you can do things as like limestone, you can do granite, whatever sort of local to your area. You'd really just want something that's going to be angular. You don't want rounded pea gravel because that still has the potential to sort of slip against each other. So you're going to use a nice angular crushed stone, or you can go concrete. And concrete allows you, with the GeoWeb system, allows you to eliminate the need for internal reinforcement. So things like rebar or fiber reinforcement you wouldn't need if you're using the GeoWeb system. And the cellular network of a GeoWeb panel creates basically little mini check dams that provide protection for the upper layer of that soil or stone against hydraulic erosive forces. So as water's flowing across the top, say from a dam overtopping, you're not going to have, an erosion effect or any sort of detrimental effect to your protection material. It's all going to stay confined within the GeoWeb panels. And when you do use the vegetated option, we're going to typically recommend getting it covered with an erosion control blanket or a turf reinforcement mat, an ECB or a TRM, and that can help you withstand some really high velocities and shear stresses. And that way it allows for full grass growth to happen before, or so that the soil doesn't get washed away before that grass starts to grow. And you can also then have that stone or concrete if you need it to be sort of a hard armor protection. Something to keep in mind with stone, it is still going to be permeable, so water can flow vertically through the system. So it can be allowed to percolate in the groundwater system. Concrete, obviously not permeable. It's good if you need to collect the water and direct it into certain places. So also things to keep in mind for whatever your project specific needs are. Okay, so one of the best things about the GeoWeb system is how much trust we have in the system working. That's because we have the experience and the research to back up what we're saying. We did a large series of tests at Colorado State University in Fort Collins, Colorado, under the direction of Dr. Chris Thornton, who is one of the leading hydrologists in the United States. And CSU is considered one of the top hydraulic research facilities in the world. And it is kind of unique because it's located under the Horseshoe Reservoir and has a couple 100 feet of static head to achieve some extremely high velocities and shear stresses. And it's just not something that you are going to be able to replicate in a lot of lab facilities. They have a very unique location here that allows them to have some pretty comparable real world testing applications, so that you're not just succeeding in a lab environment, you could actually succeed in the real world. So the system was tested using different infill materials. So we'll start with the vegetated one. It had two main objectives for the vegetated system. The first was to withstand high velocities and shear stresses. So those main components of what you're going to think about when withstanding water flow. And the second objective was we wanted to compare the performance of the topsoil filled GeoWeb compared to things like riprap and other conventional vegetated solutions such as erosion control blankets by themselves. And so you can see we have some pretty impressive test results, peak velocities of over 30 feet per second, and that's going to be with zero topsoil loss. So once you have that full vegetation growth, so all that grass is in place, you're not going to start losing soil to erosion. It's all going to stay in place. That grass is going to stay in place, even with these really intense water flows over the top. And so it can, like I said, get that up to about 30 feet per second in velocity, 16 FPS for shear, or 16 pounds of shear without failure. And so if we look at it compared to things like bare soil or 12-inch riprap is there in the middle, or even high performance turf reinforcement mats. So just basically a blanket that's laid over the top of the soil. It is significantly better. It's twice as good compared to those typical solutions. So definitely something to consider if you know you're going to have those higher velocities on your site and you still want to have that sort of natural aesthetic with topsoil. So we also then tested with aggregate stone. And so we did a couple different stone sizes, different cell sizes, a lot of different applications, and we created a regression analysis. And it's the big, long, complicated regression analysis that we're not going to talk about specifically, but it essentially allows us to determine what size stone can be used and be held within the GeoWeb panels and prevent rock loss. And that's going to be what we're looking at here. We want to see how fast can the water be flowing over the GeoWeb system without losing the stone. Because if you start picking up the stone and moving it, the system doesn't work. That's erosion. That's not what we want. So we want to see how small of stone we can get to avoid having to use large riprap stone. And so the results were really impressive. If we remember going back to the vegetated system, remember 2 whole slides ago, we were talking about 30 feet per second max velocities. With the stone system, it's actually a little bit less. It's around 15 feet per second. So might seem a little more counterintuitive, but if you think about it like this, where you have the strength of properly rooted grass compared to a single stone, it makes a little more sense that the grass can withstand higher velocities, because we're looking at preventing even a single stone from getting picked up and moved by the water. That's what we're trying to avoid. And so really what we're trying to compare is then the reduction to large riprap stones. So think 12, 14, 18-inch riprap stones. We can get down to 1-inch, 2-inch crushed aggregate, which is going to be cheaper. It's going to be easier to get. It's going to be easier to get to your project site. So it's going to save a lot in those terms to use the stone. So another thing sort of to keep in mind with water flow, you don't necessarily want to have vegetation if you're going to have constant water flow. There are some types of vegetation that like water, but generally if it's going to be submerged all of the time, you're not going to get good vegetation growth. So if you know that you're going to have that constant water flow, using stone is going to be a better option because you can be able to withstand being underwater that whole time. So something to keep in mind. We're more than happy to talk about what infill material might be the right choice for you if you don't have anything specific in mind that you're thinking about. So different applications call for different terms. And then last type of infill is going to be that concrete. So it can be poured directly into the GeoWeb panels. So you don't need to have additional formwork. You don't need to have additional internal reinforcement such as steel rebar. The GeoWeb cell walls act as both. And the confinement also allows for the use of easier to place higher slump concrete and assures a uniform concrete depth. We generally recommend around 3,000 to 4,000 PSI concrete strength. Pretty typical, pretty easy to achieve. We're not asking for anything super high strength. And you can withstand incredibly high velocities. So specifically the tests at Colorado State University achieved velocities of 36 feet per second. But that's because that's as fast as the flumes can handle. We actually overtopped the flume because we were trying to get the water to flow so quickly. We've seen significantly higher flows successfully handled at projects in the field. So if you do have these incredibly high flows, concrete is going to be the option you want to take because you know that it's not going to get picked up. It's not going to get moved. The water's not going to damage the concrete. And so basically you lay the GeoWeb panels down on your slopes. You can put them on just the side slopes. You can put them on the channel beds. You can go up and over a dike. You have lots of different flexibility there. Pour the concrete directly in, screed it flush with the top so that it all looks good. And then you just let it set and it's good to go. You don't need to do anything else to it. You do have a lot of flexibility with it. You can actually see we picked up a filled GeoWeb panel, so it's filled in with concrete and it is able to sort of bend and flex. So you can have a lot of flexibility in the field to go over sort of natural contours, to go around corners, over dips and hills, to go up over a dike if you want to, that sort of thing. So you're not limited to form work, which is typically very static and creates nice, straight, perfect lines. This allows you to be a little more flexible and have a little bit more of a natural look. And so again, pretty impressive results for the concrete system. Like I said, max velocity from the test was 36 feet per second, but that is as fast as the flume went. It does go, or does allow for much faster velocities. We've seen that successfully done in the field. So if you do have some questions about that, we're more than happy to talk about that more with you. And then I also just want to say the GeoWeb system is the only geosynthetic ever tested at Colorado State University, including articulated concrete blocks, TRMs, ECBs, all of that stuff to actually max out the flume. So we were the ones who did the best performance that pretty much Colorado State had ever seen at the time. So we are very confident that it's going to work for even the most challenging of projects. So like I said, we really trust that the geosystem is going to work because we've seen it tested, we've seen it successfully done in the field. We stand behind what we're doing here. Okay, so now let's do some case studies. Everybody likes to see these sort of things actually put in the field. We want to know that it really does work in real world applications. So our first one is going to be at Mud Lake Dam in Gardnerville, Nevada. So this was a 100-year-old earthen dam that no longer met safety standards and needed to be rehabilitated. So a cost-effective alternative to traditional reinforced concrete was needed because of budget concerns. So they ended up using a woven geotextile and then a polypropylene geomembrane and then another woven geotextile on the slope of this dam due to some environmental concerns. They were worried about some chemicals and particulates being integrated into the groundwater system. So they did this kind of like sandwich of a geomembrane. And that was what the slope was when the geocell was placed. So this is what we had to work with. So we weren't necessarily placed directly on native earth. We were placed over this geosynthetic solution that we had to work with. And so this is something that the GeoCell and GeoWeb system really excels at, being able to work with other geosynthetic solutions in a way that you might not necessarily see with traditional methods. Because we were able to place the GeoWeb system over this geomembrane without puncturing it, without needing to anchor anything into the geomembrane, so they were able to have a really steep slope. And so we were able to do that using that tendon system. We talked about it a little bit earlier. So it was able to lay directly on the slope face over that geomembrane without needing to be punctured or anchored on the slope face. It was just anchored at the crest of the slope. So it was a really sort of unique solution that they were looking for, and the GeoWeb system was able to provide a solution. So with those tendons and the Atra tendon clips, we were able to do pretty much all of the pre-assembly off the slope. So we were able to do it sort of off-site, where it's a lot easier, safer, and faster. And so this is going to minimize the amount of time that the contractor has to spend on slope. And this is really good if you do have steep slopes where they need to have harnesses or fall restraints. You want to minimize the amount of time that they are in those for safety concerns, and also just construction time that always just adds a lot of extra. So being able to pre-assemble everything off of those steep slopes is a great thing. And for this one, we're able to use our thinnest GeoWeb. It was only 3 inches deep. And so we were able to lay that on the slope face, fill it in with concrete. You can see they were filling in just from the top to the bottom, and you just rake the concrete, make sure it fills in all of those cells, and then you screed it flush with the top, so you have that nice uniform 3 inches all the way down the slope face, and you don't have to worry about it sort of slumping to the bottom and having a thick toe with a thin veneer at the crest that could potentially crack or break. You have that nice uniform thickness the whole way through. And so the GeoWeb alternative cost around $10 a square foot installed. And so we were able to offer a significant cost savings, over $500,000 on a 90,000 square foot project. So a savings of roughly $6.50 a square foot, or about 40% compared to a traditional reinforced concrete. And that's going to be a pretty typical type of cost benefit analysis when using the GeoWeb system. The GeoWeb material itself might be slightly more expensive up front, but when you consider the fact that you can have thinner cross sections, you can use on-site materials if you have them, you can use the small stone compared to large engineered riprap, you could use topsoil and vegetation. Those sorts of things will save you a lot of money. And also being able to put things in a lot faster and in a safer capacity also is going to save you on construction times, material costs, hauling costs, all of that stuff. So the type of cost benefit analysis is not 100% straightforward. You can't just say material to material. But if you look at the overall, typically we are on par or cheaper than a traditional method. Okay, so moving to a vegetated solution. So this one was done on the dry side of a dam. It was Lake Hefner Dam in Oklahoma. It was experiencing some erosion damage along the bank and underneath the road that was on the crest of the dam due to a number of years of overtopping. So the dam had actually overtopped and had gone across this roadway and then down the dry side of the dam and was causing some pretty significant erosion issues. You can see it was starting to undermine the road, just cause some pretty significant cracks. They wanted to fix all of this and then prevent it from happening again. And so the overtopping had been due to excessive rains in the area, and then high winds had actually created higher wave action than typical and was pushing that water up over the engineered riprap on the wet side, up over the crest of the dam, and then down the dry side. And so the lake side of that dam got a whole new set of large engineered riprap stone. That was not something that we were part of. It was done before we were brought in, and they realized that they were just sort of redoing what they already had, which wasn't working. So they knew they needed to come up with a new solution to protect the roadway and the dry side of the dam. So the GeoWeb system was installed on the opposite bank, and so you can see that being placed here. Because it was a relatively shallow slope, they were able to use stake anchorage. So instead of having to do tendons and crest anchorage, they were able to do stakes along the slope face to hold those GeoWeb panels in place. And then you fill it in with topsoil, seed it with grass, let that grass grow. And once the grass is fully grown, you're not going to see the plastic. You're not going to know that the GeoWeb system is there. It's just going to look like a full green lawn or full green slope in this case. So no one's really going to see it and think, oh, they just put plastic on the slope. It looks awful. It is just going to look like grass. And you know that now it's going to be able to withstand any potential overtopping and sheet flow because the GeoWeb system is going to hold that vegetation in place. It's going to make sure that that grass is nicely rooted. It's going to be good, strong roots to the grass. The water can flow over the top and collect down in the drainage ditch at the toe, and you're not going to have erosion and sloughing on the slope face. Everything's going to stay in place the way it's supposed to. And finally, we do have a concrete filled dam. So this was a Hickory Mound impoundment down in Florida. And so they were looking for a solution to be able to drive over the crest of the dam and then also the bottom of the pond when they drained it for maintenance activities. So with concrete filled GeoWeb covering the crest of the dam, the side slopes, and then even the bottom of this pond, they were able to create a smooth, drivable surface. And so you can see what it looks like here. It looks like just your standard concrete road. You're going to be able to support some pretty heavy vehicle loads on here. Like I said, you can get all the way up to AASHTO H20 loading. So that's going to be highway rated vehicles. It's going to be emergency vehicles. It's going to be light construction equipment, anything like that. So this is really good for maintenance of a dam, or in this case, an impoundment, so that they were able to get any of the equipment that they needed anywhere on site by driving over this GeoWeb concrete area. So good solution here. We also can just do spillways. So that's a pretty common example of the GeoWeb system. So if you aren't looking to protect an entire dam face, or you don't need to go up and over an entire dike, you can just do a small spillway section. So this was a project in Tallahassee, Florida, where they were collecting water into a detention pond. And so they needed to have this flume and spillway apron protected. And they knew that it was going to be capturing stormwater runoff that had the potential to have some really high flow rates for admittedly short periods of time just during storm events, but it needed to be able to handle those really high flow rates. And they wanted to have as little maintenance as possible. They really needed to be able to place it and forget it. And so what they were able, only one picture of that one, my bad. And so with this, they were able to put the concrete down and collect all of the water from everywhere on this project site and then funnel it into this detention pond with the spillway filled with concrete filled GeoWeb. So you don't need to put it anywhere else. You don't need to have it in, on the top of the dams or excuse me, the top of the ponds or anything. You don't need to protect the bottom of the pond if you don't have to. You can just place it in the small area of the spillway to withstand those high flows. And so this was going to be another example of a hard armor solution. This was at a country club up in Pennsylvania. And so this was also going to be concrete. And so this is a good example to show that you don't actually need that formwork. So typically you've got to build up your formwork and then place your concrete. And you really have to have really low slump concrete so that you don't all just let it slump to the bottom and have that thick toe of concrete. You don't need any of that with the GeoWeb system. The panels go directly where they need to, in this case, a pretty small confined spillway area, but they can be placed directly on site, and then you pour the concrete right into the GeoWeb panels. And then you have this nicely formed spillway, can handle those nice high flows for when you need it to, and otherwise it's just going to sit there and it's going to be good. And you have that flexibility, so you can see it's going around curves, it's going up and down a little bit, following some of the natural contours of the land, let you have a little bit more natural look, even if it is concrete, which is obviously not a natural look, but it does give you some aesthetic appeal if you want. Okay, so that's sort of what we covered today. We looked at some of those innovative solutions for dams, dikes, levees, and spillways. Before we do get to questions, I want to remind you that we provide a complete solution, and part of our technical assistance is going to be working with the engineering team here, including myself, where we're going to offer a free project evaluation service. And this can be for roads, embankments, any sort of erosion control projects, or if you have projects that might fit one of our other product areas that I mentioned briefly at the beginning. So we do have a form on our website's prestogeo.com. So you fill it out with as much information as you have. You can attach some documents such as geotechnical reports or site photos, and it comes to myself and the rest of the engineering team. And then we are able to provide a recommendation evaluation for you. And this is going to tell you what we recommend for infill materials, what your anchorage requirements might be. We're going to have supporting calculations. We're going to be able to provide CAD details that you can insert directly into your plan sets, all of that good stuff. And so we're going to work with you to get the best design for your project. So like I said, it's not a one size fits all. There is a lot of flexibility in the GeoWeb size that you choose, what info material you use, what anchorage is required. So we're going to work with you to get sort of that best case scenario for you. We also have what we call our Spec Maker tool. This is something on our website that allows you to create full specific CSI specifications for your project. It comes out as a Word document. It takes about 4 minutes to fill out the full Spec Maker thing. And it's going to give you everything that you need to be able to insert right into your specifications for your bid documents. And it's typically going to be something that either we can provide for you or you can make yourself to go with one of our evaluation recommendations. So it's something that you can have to sort of back up our recommendations. So here's the specification to go along with it, so that you know when you go out to bid, you're going to get the materials that you actually want, and you're not going to get an inferior competitor product. And so we do deliver quality and over 40 years of expertise. We guarantee each shipment meets or exceeds our specifications, so you can deliver certainty and build with materials that you know you can trust. We have no disclaimers. We have no fine print, nothing that is going to say, well, it'll probably work, but, good luck. We're going to work with you. We're going to stay with you until you know that it's a successful project. So hopefully we covered all of the learning objectives to your satisfaction today. If you would like to discuss anything specific in detail, feel free to reach out to me directly. If you have any projects that the GeoWeb system would work for, great. If you have some where you're just questioning and you said, well, I don't know, maybe this could work, I'd be happy to talk about it with you. Like I said, everything that we offer in that regard is free, free recommendations, free advice, that sort of thing. Always happy to take a phone call. So definitely sort of put us in your back pocket. Think of us next time you've got one of these type of applications. We'd be happy to talk to you. A little bit of housekeeping before we finish. We've made it faster and easier for you to obtain your PDH certificates. I know that's something that a lot of you are hoping to get out of this webinar, and I do not blame you. So we have what we call our webinar dashboard. So this is where you can view our library of webinars and download your PDH certificates for any on-demand webinars that you've completed. So the webinar dashboard is going to keep a record of any of the on-demand webinars that you've watched along with those PDHs. So please note that the certificates for live webinars, which if you're watching on Tuesday, June 6th, it is live and it's going to be sent to you directly from GoToWebinar. So you should get it within the next 24 hours. So keep that in mind. Maybe check your spam folder if you don't see it for something for GoToWebinar. And then if you are watching this on demand through the webinar dashboard, you can download your PDH certificates directly through that dashboard. If you don't receive any emails, if you think you need the PDH certificate and you're not seeing anything, feel free to reach out to us and we can try and help you determine what you need to do to get that certificate, because I know that they're definitely helpful. So that is the presentation. Thank you all for attending. My information is on the screen. Like I said, feel free to give me a call at any time. Call, email, happy to discuss our products. Like I said, the research and testing behind them, if you've got any projects that you want to discuss, anything like that. So looks like we have a little bit of time and there's some questions that came in. So I'll go through those. If you do need to log off today, I want to say thank you again for attending. The questions are going to be recorded, so you can get on that webinar dashboard and jump to the end and listen to the Q&A session if you can't watch now. And so let's get started with that. So one of the first questions, why not use recycled HDPE? So that's actually a fairly decent question. A lot of people are really into making sure we're taking care of our environment. We have plastic that we know isn't degrading, so why not recycle it? Why not try and reuse it? And unfortunately, we decided that it's just not going to provide an adequate product to use recycled HDPE. Because when you have recycled material, you can't confirm that it was what it was specifically made out of, what its properties were when you started, and you're going to have variability in all of that recycled material. And that leads to the potential of weak seams or areas where it's not as strong and as durable as it needs to be. And so by using a virgin HDPE, using fresh resin for all of our materials, we can confirm that everything is going to meet our specifications. It's going to be as strong, as durable, and as long lasting as it needs to be to meet your product or your project. And we really just don't want our materials to degrade before your project lifetime is over. And that's something that we're promising you, that we have this product that is going to last. So to do that, we need to use that virgin HDPE. But that's a good question. It definitely is important to think about those environmental concerns. We do use recycled HDPE for some of our other products. Our porous pavements and our construction mats use recycled HDPE. So we definitely do that where we can. And if you are interested in that, happy to talk about that with you on a one-on-one. But that's sort of the idea of why we use virgin material. Let's see, what are some of the other questions here? So using the GeoWeb system for really small applications. So things like parking lots, sidewalks or walkways. Can you get small quantities basically? And yes, so we sell through a distribution network, so there's going to be a distribution warehouse local to you. In the United States, there's going to be at least one in every state. There's going to be at least one in every country as well, so that we have the ability to get the material to you quickly and easily. And through that, you can buy as much or as little of the material as you need. So you can build, you know, the smaller projects. You don't need to be building 100,000 square foot projects every single time to use this material. You can build small parking lots, you can build walkways, you can build you know, handicap accessible ramps, that sort of thing, all with the GeoWeb system in small quantities. So if you are interested in using this but think, oh, I'm too small of a project, you definitely don't. We've done really small quantities before. Please reach out. We're more than happy to work with you on that sort of thing. So some questions on reinforcement of the concrete. So does it need any internal reinforcement? Is there any potential for undue cracking with the concrete? And so no, you don't need any sort of internal reinforcement for the concrete. You don't need steel rebar. You don't need fiber reinforcement. You don't need anything like that. The GeoWeb cells themselves act as both the formwork and the internal reinforcement. And so what this does is it creates controlled cracking. So it's going to crack along the rhomboidal shapes of the GeoWeb cells. That allows for that flexibility that I showed, some of the pictures where it's really flexible, but it means it's not going to crack anywhere else. So you don't need to put like tension cracks in, or you don't need to, you know, do pre-stress cracks to prevent it. That's already happening with the GeoWeb system. And so that really allows for, you know, high water flow to go across it. You can have heavy loads drive across it without the worry of it creating cracks that are then going to propagate and spread and lead to failure of the site. None of that's going to happen with the GeoWeb system. Looks like we have time for one more question. Any experience using slope stability on soft clay soils along lake shores? Yes, so that's actually usually a pretty big issue along lake shores, is you have those really saturated, really soft soils. You're not really working with the best of material along lake shores. And so the GeoWeb system actually does really well in these conditions. You can place it over those soft soils and do just crest anchorage if you don't want to disturb them, or you can use the stakes and do anchorage along the slope face. All of that's going to work, and the softness of the soil is not going to affect how the GeoWeb system functions. The GeoWeb system adds strength to the soil. There's not a detrimental effect because the soil is soft. So it is definitely something that has done really well on those soft soil conditions. It does really well in those saturated, you know, lakeshore conditions where the water level is rising and lowering and you're not entirely sure where the water is at any given day. The GeoWeb system does really well in those conditions. So definitely good question. It's really a great place for the GeoWeb system. And so with that, I am going to end our presentation today. Thank you everybody for attending. Please feel free to reach out to me. Phone and email are on the screen, and I would be happy to discuss any other questions you may think of, or if you have any projects you want to discuss. So thank you everybody. I hope you all have a good rest of your day. Bye.